Define, can you voice? Everyone, please give your attendance at first. Okay. Okay. All of you, can you hear my voice clearly?
No, sir.
Okay. Can you see my board clearly?
Yes, sir.
Okay. Thank you. So, in our previous class, we already discussed about the singularity and also the pole of order. Um, Today, I'm going to show you the another topic, which is residue of the function. Okay. So this is our topic today. Today's topic is residues of the function. Okay. So at first, all of you knew about Taylor's theorem. Uh, I hope so. So here, at first, I just give the statement of Taylor's theorem, also the Lorentz theorem, and after that, I just show you the definition of residues and how to find the residues of a function, and step by step. At first, the Taylor's theorem. These are all connected for finding out the residues of the function. Uh, can you please tell me, do you have any idea about Taylor's theorem? Anyone? ওকে, এটা তোমরা ইন্টারে করে আসছো। টেইলরস থিওরেম এগুলো নিয়ে তোমাদের ছিল ইন্টারে টপিকগুলোতে। তো
Residue.
হ্যাঁ বলো। ইয়েস প্লিজ।
Sir, f of x plus f dot
Yes.
f prime x plus f double prime x by 2.
হ্যাঁ অনেকটা ওই টাইপের। ঠিক আছে, তো আমরা এখন
f of
শিখবো
x
হচ্ছে ফর ইয়েস। তো আমরা যেটা শিখবো সেটা হচ্ছে কমপ্লেক্স ফাংশনের জন্য হোয়াট ইজ আওয়ার Taylor's theorem. Okay, so if fz is analytic for all values of z inside a circle with center A as A, then we can say the statement of Taylor's theorem fz equals to fa plus z minus a f prime a z minus a square divided by 2 factorial into f double prime a. So this is a statement of Taylor's theorem for complex function. Okay, so here fz equals to f of a plus z minus a into f prime a, and also plus z minus a whole square divided by 2 factorial f double prime a up to n terms or infinity. So now আমি জাস্ট তোমাদেরকে স্টেটমেন্ট সম্পর্কে আইডিয়া দিচ্ছি। এগুলোর প্রুফগুলো আমরা নেক্সট ক্লাসগুলোতে শিখবো। আমাদের আজকে মেইন topic or theme হচ্ছে residues, and these are connected with these formulas. Okay, so at first another one is Lorentz theorem. Okay, E F boundary of the free shape. Bounded by two circles. Are one thing. So if there is analytic inside and on boundary of the ring shape region, so ring shaped region are bounded by two concentric circles C1 and C2, beta circle C1 and C2, with the center A uh, respective, and the respective radius are R1 and R2, where R1 is greater than R2, then our uh, Lorentz theorem can be denoted as Fz equals to summation of equals to 0 infinity a and z minus a to the power n plus summation, yeah, for after infinity this is 10 divided by z minus a to the power. So this is our Lorentz extension, which is Sz equals to summation in 0 up to infinity an z minus a to the power n plus summation n equals to 1 up to infinity a minus n divided by z minus a to the power n. Okay, where an 1 by 2 pi I.
স্যার সেকেন্ড টার্মটা কি a মাইনাস n?
কোনটা? eta n equals to 1 to the infinitive, and here z minus n, and that means to say subscript. Okay, subscript n minus n. And it can be noted as w step n plus 1 till w, where n equals to 0, 1, and also here a minus n equals to 1 by 2 pi I, and also this is 1 if w divided by w minus a to the power minus n plus 1 dw, where n equals to 1 to so this is our Lorentz expansion. Okay, and এখান থেকে আমরা এখন next যেটা দেখবো definition of residues, okay, of a function. So it's a residue. So function. Let's say like this with a circle P and center A set.
Keep it out.
Yes, yes. Then the curve is one of 1 by z minus a in the Lorentz function. And the Lorentz expansion is okay. আমরা এর আগে দেখেছি what is the Lorentz expansion, which is fz equals to summation an and also z minus a to the power n, and also summation a minus n divided by z minus a to the power n. So here you can say n equals to 0 to infinity, and this is n equals to 1 to infinity. Okay. So from here you can also write this way, which is a naught plus a1 z minus a plus a2 z minus a whole square. Also plus this is for this term, and again for this term you can say plus, which is a minus 1, where
Yeah, what is it?
previously I also told
Oh, yes.
here an, where
I already.
n equals to 0 to infinity, and here also a minus n, that means a minus n, here n equals to
Last year, but happy you. I don't want last year be so.
I don't get it. Yes, Keto, again, please. Now here you can say z minus a. Also, you can say minus 2 also z minus a square. So this is a Lorentz extension. From here, you can also define the residues of the function. So here, around z equals to a is called the residue of f z at z equals to a, and it is denoted by raise a, okay, raise a or a minus 1. Okay, so you can define the residues of the function by raise a or a minus 1. Now, this is the definition of residues of the function. Now I will show you the theorem of related to residues of the function. Okay, so let f z be analytic and on a simple CLOSP closed curve space except z equals to a, okay, except at a point a inside C, then if z equals to a is a simple code, then a minus 1 equals to limit z tends to a z minus a lz. So this is very important. Here, let's take a look at. I just mentioned here simple form of a function. Okay. So in our previous class, we already discussed about singularities of a function, where I also declared some pole of order n. How to find out the poles of order n? এটা আমরা বের করতে শিখেছিলাম। So simple poles means হচ্ছে single pole বলা যেতে পারে, এটাকে one kind of single pole. So if I say if you have to find that the simple pole of a function, and then if I say that find out the residues of this simple pole of the function, then the formula is a minus 1 equals to limit z tends to a z minus a into lz. Okay, so I will give you the example. At first, just prove this here. The corresponding Lorentz extension. Okay, so we have to use the Lorentz series for proving this theorem. Here, you know, is equals to summation a in z minus a to the power n, where n equals to 0 to infinity. And also here n equals to 1 to infinity. Also a minus n divided by z minus a to the power n. Okay, so this is our Lorentz extension. Here you can write this equation which is summation equals to 0 to infinity a n z minus a to the power n plus 1. If I take only 1, z minus a here not equals to 0. Now, just multiplying z minus a on both sides, you can get and taking the limit. Taking the limit, you can get your limit z tends to a as z tends to okay. To get z minus a into l. Just multiply here by z minus a and also take the limit z tends to a. You can get your required answer or the residues of the function. Okay, so here you can say limit z tends to a also z minus a multiply 1 also z minus a into z minus a. Okay. So from here you can easily say that, and that is it tends to 0, so it tends to a, so that means it turns into 0, and here you can also say this is a minus 1. So this is a subscript minus 1 equals to limit z tends to a z minus a s. So this is the residues for a simple pole of a function. Okay. So residue of a simple pole of a function যদি বের করতে বলি তাহলে তার ফর্মুলাটা হচ্ছে a subscript minus 1 equals to limit z tends to a z minus a into LZ. Now I show you an example. So here, just for simple pole, okay. Find the residue. Okay. So here find the residue of the function. F z equals to z square divided by z square plus a square. Okay. So I just use the simple one. Okay. So here, just tell me what is the singularities of this function, just find out the pole of this function. Can anyone tell me the answer? Anyone? Okay, so for finding out the pole of this function, you have to at first declare your z square plus a square equals to 0. That means the denominator equals to 0. And from there, you can find out the singularities of the function or the pole of the function. So here, you can say, so the pole of a or object by z square plus a square equals to 0. Okay. So from here, you can say it is a square minus a square, and also this is a square into I square, where I square equals to minus 1. Okay. Now you can say that the values of z equals to plus minus a I. Okay. So this is our pole of order n, where n equals to 1. So here you can say that this is the, here you can easily use the simple pole of a function for individual values of z. Okay, so here z equals to ai and also minus ai. Those two values are different, so you can find the simple pole of this different of a function by using these different values of z. Okay, so if I take the positive value, only say ai, which is simple pole, then residues of at state equals to ai is. So what will be our formula for finding out the simple pole residues of the simple pole? Anyone? If you both what is the formula of residue for a simple pole of a function? It's okay, আমরা একটা theorem proof করা শিখেছি, তাই না? সেটা কি ছিল? A swap equals to limit z tends to I just normally just formula বলি, formula ছিল which is a z tends to a z minus a z. Okay. So this is the formula for the residues of a simple pole of a function. Okay, so here a subscript minus 1 equals to limit z tends to a z minus a into lz, where z equals to a zero. So here for z equals to ai, you have to find out the simple pole of a function or residues of the function. Okay. So সেই ক্ষেত্রে এখানে কি হচ্ছে? Just compare it with this formula. You can say this is z tends to ai, and also z minus a means what? Z minus a means ai. Okay. So just z equals to a. Just replace z is division by a minus ai. Sorry. So after that you can get a minus 1 equals to limit z tends to ai, z minus ai into lz. So what is our lz? Lz here is z square plus z square plus a square. Okay. Simple. Okay, everyone. Got my point?
Yes.
Okay. So now just you have to solve this equation, which is limit here z tends to ai, and also here z minus ai, and also you can get here z plus ai, and also z minus ai. Okay. How can I write this? Anyone?
Sir, z square plus a square can be written as z square minus a square I square.
Yes. So usually a square plus b square, a square minus b square formula, if I convert it z square minus a I whole square. Okay. Then you can say z plus ai and also z minus ai. Okay. Now just these two are transferred. Now you can say limit. It is z tends to ai, also z square here, z minus ai. And after that, just so it is a plus a. So here these two are so ai here z square divided by a plus ai. And after that, we just put those values here, which is ai square and also ai plus ai. And after that, we can say this is minus a square divided by 2ai. Okay. So, and here we can also write a by 2. So, okay. And again, we can also write this ai square divided by 2i, which can be written as ai by 2. So, this is answer for positive value ai. Okay. We can also find out the residues of this function by using the negative values. Okay. যেটা আমরা পেয়েছিলাম z equals to plus minus ai, তাই না? একবার আমরা ai দিয়ে বের করতে পারো এবং সিঙ্গুলার হয়েছে একই ফর্মুলা ইউজ করে you can find out the residues of the function for negative value. So this is for the formula for finding out the simple form of the function. And also the residue. If suppose your fz equals to z square minus 2z divided by z plus 1, also here z square plus 4. Now I have to, at first I have to find out the pole of this function. So here if I say the denominator equals to 0, then you can find z equals to here is the square. Okay. So for this you can say z is equal to 4. that, we can say here the values of z will be -1 and also -1 because power is 2. So here you can say the values of z is first one is -1 and also -1, and for this value you can say plus minus 4, sorry, 2i. Okay. So here z equals to different values, which is 2y and also -2y. So you can also find the residues of a simple pole of a function where z equals to 2y and also -2y. And the formula is a substitute -1 equals to limit z tends to a z minus a into fz. Okay, this is for the formula of, for simple pole. Okay, but if here z equals to -1 and also -1, so সেই ক্ষেত্রে আমাদের ফর্মুলাটা কি হবে, and this is called the double pole of this function. Okay, যদি তিনটা হতো, if the values rising -1 -1 and also -1 এরকম করে এগুলো আমার higher pole হচ্ছে. Okay, তো সেই ক্ষেত্রে you have to apply another formula which is formula is -1 to a tends to a. So 1 by n -1 2 to the power n -1 Okay. So this is the formula for finding out the residues of a double pole or higher pole. Okay, ঠিক আছে, higher order pole. So এখানে আমরা যখন দেখছিলাম z equals to 2i, তখন simple pole ইউজ করছি ফর্মুলা, বাট when again also z equals to -2i এর জন্য আরেকটা ফর্মুলা ইউজ করছি, সেটাই z equals to তোমার a করে সেখান থেকে আমরা যে ফর্মুলাটা জাস্ট সিম্পল পোলের জন্য এসেছিল সেটা ইউজ করছি, but here z equals to -1 and also -1. So that's why you have to apply for derivative formula here. Okay, so you have to apply this formula for find out the residues for double or higher order of pole. Okay, so next class I will also explain or prove this theorem, and after that show how to find out the residue of this function. Okay, clear everyone? Thank you everyone.